Hello viewers, welcome to my channel. I'm Hasham. Last 3 videos I have explained you about the theory of network analysis. Now in this video I'm going to start the problems on network analysis. Actually, network is a graphic presentation of a complex project. A project consists of so many activities. It has beginning and end. So in a project network, we have to make the relationship of different activities, showing the precedence and succession of all the activities, how much time duration is required for completing the project, for completing each of the activities. All these things I have already explained in the previous 3 videos. So if you have not watched, I suggest you go to the playlist of my channel, select the subject operations research, select the videos of network analysis. Be perfect about the concepts which are used in network, like what is activity, what is event, what is dummy activity, what are merging events, busting events. All these things I have already explained. Be perfect, then come to the problem. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Without having the problems, you cannot understand my lecture. And always keep a pencil, notebook, calculator ready while watching the video, because whatever I'm explaining, you will simply forget it if you only listen. Apart from listening and watching, you must make some notes of the important points which I'm explaining. So first problem on this network. Given the following information, develop a network. So starting 4 or 5 problems, I'm going to explain you how to draw the network. Later we'll go for calculative parts. So first of all, you must know how to draw correct network. So here, given the following information, develop a network. Activities are A, B, C, D. 4 activities are there. And for each activity, immediate predecessor is given. Predecessor means before that activity, what are the other activities? So for A activity, there is no predecessor. For B activity, there is no predecessor. That means A and B will start at the same time. Then for C activity, A is the predecessor. For D activity, B is the predecessor. So now we have to draw the network diagram for these 4 activities. Now see carefully how I am drawing. First of all, A and B. There is no predecessor for A and B activity. So this is A activity and this is B activity. See carefully here. This is the A activity and this is the B activity. Activity is denoted by arrow and circle is the event. Circle is the event. There is no predecessor for A, no predecessor for B. And C follows after A. After completing A, C activity will follow. So this is the C activity. And D follows after B. So after completing B, D follows. This is the D activity. So all the activities will start with an event and all the activities must end with the event. Right? So there is no predecessor for A, no predecessor for B. That means A activity and B activity are starting from the same event. Now we can give the numbering to the event 1, 2, 3 and 4. That's all. This is the first problem on network. How to draw the network. Very easy network. Now second one. Given the following information, develop a network. Again we have to draw. A, B, C, D, E. 5 activities are given. For A activity, no predecessor. B activity, no predecessor. Just like the previous case. Then C follows after A and D follows after A. That means after A activity, 2 activities are following. That is C and D. And E activity follows after C and B. That means B and C should combine. So after combining B and C, E activity is succeeding. That's it. Now we'll start the second problem. A, B, no predecessor. So this is the A activity, this is the B activity. This is A activity and this is B activity. No predecessor. Then C follows after A and D follows after A. So after completing A activity, two activities are following, C and D. So I will take this is C and this is D. C and D. This is D. Now see carefully. C and D follows after A. E follows after B and C. So E activity will follow after B and C. B and C should combine. That's why both the arrows are meeting here. So now here E. This is D. D follows after A and E follows after B and C. This is E. Now you can see here there is no predecessor for A, no predecessor for B. C and D follows after A. So after A, D follows and C follows. C I am coming and joining here. Why? Because B and C are the predecessor for the activity E. So activity E should be done after completing B and C. So B and C are merged here. So the numbering 1, 2, 3 and 4. That's it. This is the end of problem number 2. Two problems I have completed. We are drawing the network. Third, given the following table, develop a network. Beginning event, ending event, activity. Previous problems activity names was given A, B, C, D, E. But here activities are given from event number to event number. For example, first activity 1 to 2. That means from first event to second event. Beginning event is 1, ending event is 2. Second activity 1 to 3. The beginning event 1, ending event 3. So instead of giving the names, here it is given from where it is starting and where it is ending. Right? So first activity is 1 to 2. Second activity is 1 to 3. Now see carefully how I am drawing. So 1 to 2. This is 1 to 2 and this is 1 to 3. This is 1 to 2 and this is 1 to 3, right? Then 2 to 4, 3 to 4. 2 to 4. Here I will write down 2 to 4 and this is 3 to 4. Then 3 to 5. Here I am taking 3 to 5. This is 3 to 5. Then 4 to 6, 5 to 6. Here I will take 6. This is 4 to 6 and this is 5 to 6. That's all. Over. Network diagram completed. It requires a lot of practice. After watching this video, take the problem worksheet and try to solve it. Try to make the worksheet yourself. After watching this video 1 or 2 times, definitely you will be in a position to draw the network diagram. Right? Only by practice you can get the perfection, and without hesitation in examination you can be able to draw the network. Now this is the network. Next, fourth problem. A project schedule has been the following characteristics. Activity 1 to 2, time is 4. Activity 1 to 3, time is 1. Like this, all the activity time is given. So we write the time on the arrow. On the activity arrow, we write down the time. Construct a network diagram. Simply, we have to construct the diagram. This is problem number 4. Here I am going to construct. 1 to 2, 1 to 3. So here you can see carefully. 1 to 2, 1 to 3. Right? 1 to 2. This is 1 to 2. And here it is 1 to 3. Then 2 to 4, 3 to 4. This is 2 to 4. And this is 3 to 4. Then 3 to 5. Here I am taking 3 to 5. This is 3 to 5. Then 4 to 9. Here I am taking 9. 4 to 9. Right? Then 5 to 6, 5 to 7. So two arrows are busting from 5. 5 to 6 and 5 to 7. This is 5 to 6 and this is 5 to 7. Then we have 6 to 8, 7 to 8. This is 8. This is 6 to 8 and this is 7 to 8. Last one 8 to 10, 9 to 10. So here I am taking 10, 8 to 10 and 9 to 10. That's all. Now we have to write the time. The times are given. 1 to 2 activity, the time is 4. So 1 to 2 activity, time is 4. 1 to 3, one time. 2 to 4, 1. Then 3 to 4, 1. 3 to 5, 6. 4 to 9, 5. 5 to 6, 4. Then 5 to 7, 8. 6 to 8, 1. 7 to 8, 2. 8 to 10, 5. Last one 9 to 10, 7. The only thing is here time estimates are given. Write the time on the activity. On the activity, simply write on the time. That's all. This is the network diagram for problem number 4. Now problem number 5. See the problem number 5. Draw a suitable network for the following. Here activity names are given A, B, C, D. Events are not given. Previous problem event numbers was given 1 to 2, 1 to 3. But here activity A, B, C, D, E, F, I like that up to I is given. Duration, time estimate for completing each activity is given. This duration will be written on the arrow mark. And precedence means predecessor activity. Before that, for example, A, B, C, there are no predecessor. There are no predecessor for A, B, C. That means at the same time we are starting A, B and C. So here how to draw the network I am showing here. See carefully. This is A, this is B and this is C. A, B and this is C. A activity, B activity, C activity. There is no predecessor. Now D, E, F. The activity predecessor to D is A and E follows after B. F follows after C. And G is the activity, the predecessor is D, E, F. That means all the D, E, F must join. So what I am taking here is the D activity is following after A. So after completing A, this is the D activity, right? E activity follows after B. So this is B. After B, E activity follows. Then F follows after C. After completing C, F activity will follow. Why I am joining all the three? Because D, E, F is the predecessor for the activity G. So this is the G activity. G follows after D, E, F. That's why I have combined D, E, F. D follows after A, E follows after B, F follows after C. Now last one, I follows after G and H. I follows after G, H follows after C. After C, H follows. So C is completed here. After completing C, H follows. So we will join like this. This is H. This is H activity. H follows after C, right? Now G and H combine together because GH is the predecessor for I activity. This is the I activity. So I follows after GH. So GH should be combined. H follows after C. C is completing here, H follows, right? That's all. The diagram completed. Fifth problem completed. Now see the sixth one. With the following data, draw the network, find the critical path and the expected time. Activities are 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, 2 to 5, 3 to 5, 4 to 5. Durations are given. Achha, previous problem, durations are given. We have not written the duration. Fifth problem. A activity, the duration is 8. So A activity 8. B activity 8. Then C activity 9. D activity 3. E activity 6. Then F activity 2. Then G activity 7. and H activity 6, I activity 0. So the duration should be written on the activity. That's all. Now in the sixth problem, apart from drawing the diagram, we are required to find out the critical path and the estimated time for completing the project. Right? The project consists of activity 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, 2 to 5, 3 to 5, 4 to 5. All the activities are given. So before finding out the critical path, first of all, we must draw the diagram. Now, first 1 to 2, 1 to 3, 1 to 4. That means from the first event, 3 activities are bursting. One is going 1 to 2, second 1 to 3, third one 1 to 4. Now, see carefully here. This is 1 to 2, 1 to 3, 1 to 4. 1 to 2, 1 to 3, 1 to 4. Now, 2 to 3, 2 to 4. From 2 to 3, but 2 to 4 we cannot come like this. So what we'll do is we'll change the number here. This we make it 2 and this we make it 3. So 1 to 2, 1 to 3, 1 to 4. Now 2 to 3, 2 to 4. This is 2 to 3. This is 2 to 3. And this is 2 to 4. Then 2 to 5. This is 2 to 5. Right? Then 3 to 5, 4 to 5. This is 3 to 5 and this is 4 to 5. That's all. This is the diagram. 1 to 2, 1 to 3, 1 to 4. 2 to 3 upside and 2 to 4 down. Then 2 to 5, 3 to 5, 4 to 5. That's all. But here in this problem, after drawing this network diagram, we have to enlarge. There is no space. That's why what I am doing is I am rubbing this. Again, I will draw the same diagram with larger circle, because we have to calculate the critical path and the duration of the project. For that purpose, what I will do is I will enlarge this diagram. Now, see carefully. What I am doing is I am drawing a large circle. 3 parts I am making. The first part, event number. The first one is the event number. This part is called EST and this part is called LFT. This is the circle. The upper, this is the event number. Event number. And this is the EST value. And this is the LFT value. EST stands for earliest start time. LFT stands for latest finish time. So 3 parts are there in this circle. First event. Now 1 to 2, 1 to 2, 1 to 3, 1 to 4. This is the circle, this is the circle, and this is the circle. So 3 parts I am making for each circle, right? So this is 1 to 2, this is 1 to 3, this is 1 to 4. Now it is saying 2 to 3, so upside, 2 to 4, downside, then 2 to 5. So here I am making 2 to 5. This is 2 to 5. Then 3 to 5 and 4 to 5. That's what given in the problem. So the same diagram I have drawn with larger circle, because in this problem we have to find out critical path. We need EST, LFT values. The left side part is the EST, right side part is the LFT, and the top part will give you the event number. So event number 1, 2, 3, 4, 5. Right? Now duration. What is the duration of 1 to 2? It is 4. 1 to 2 it is 4. Then 1 to 3 it is 7. Then 1 to 4 it is 8. Then 2 to 3 is 5. 2 to 3 is 5. Then 2 to 4 is 6. Then 2 to 5 is 9. 2 to 5 is 9. Then 3 to 5 is 8. And last 4 to 5 is 6. These are the durations given. Now, for finding out the critical path and the duration of the project, we need EST and LFT values. The first time I'm going to explain you how to calculate EST LFT value. So watch with full concentration. Now first value, always the first value EST will be 0. We are beginning from 0 time, right? Now how many arrows are merging here? We are making forward pass. We are making forward pass, going from the first event to the last event, forward. So how many arrows are merging here? First of all, second event. See here in the second event, only one arrow is coming from first one. Only one arrow. So what you have to do? The EST value plus duration. So 0 plus 4. You write down here 4. Right? Now third event. How many arrows are merging? 2 arrows are merging. One arrow is coming from first event and the second arrow is coming from the second event. So whenever 2 or more than 2 arrows are merging, take the maximum. Take the maximum. How? 0 plus 7 is 7 or 4 plus 5 is 9. 7 or 9, whichever is higher. 9 is higher. So I am taking here 9. Right? Now fourth event. How many arrows are merging in fourth event? 2 arrows. One arrow is coming from first event. The second arrow is coming from the second event. Now you add up. 0 plus 8 is 8 or 4 plus 6 is 10. Whichever is higher. 10 is higher. So I am taking here 10. So we got the EST value of first event, second event, third event, fourth event. Now fifth event. How many arrows are merging in fifth event? 3 arrows are merging. So we take the maximum of these 3 arrows. First arrow, 9 plus 8, 17 or 4 plus 9, 13 or 10 plus 6, 16, 17, 13, 16. Whichever is higher. 17 is the highest. 9 plus 8 is 17. This is highest. 4 plus 9 is 13, 10 plus 6 is 16. The highest is 17. So I am taking here 17. So while taking the forward pass, if 2 or more than 2 arrows are merging, take the maximum. So we have calculated all EST values. Now LFT values. Now LFT values we have to go backward from the last event to first event. Backward. So here the last event EST and LFT values will be same. So what is the EST value? 17. LFT value also we will take 17. Now forward we have seen the merging event. Now backward we have to see the busting event. If 2 or more busting event are there, then we take the minimum. Note down all these points, whatever I am explaining, then only you can easily remember. In the coming problem, you don't find any difficulty. The same logic we are going to apply in all the coming problems, right? So, 17, 17. Now, how many arrows are busting here? Only one arrow is busting. So, we subtract. 17 minus 6 is 11. So, I am writing down 11. Here, how many arrows are busting here? Only one arrow is busting. So, we subtract. 17 minus 8 is 9. 17 minus 8 is 9. Now here, how many arrows are busting? 3 arrows are busting from this event. One arrow is going to third event, one arrow is going to fourth event, one arrow is going to fifth event. So we have to find out the minimum. Minimum of each. Here 9 minus 5. See here. 9 minus 5 is equal to 4. This is 9 minus 5. Right here. 17 minus 9. 17 minus 9 is equal to 8. Right? Now here 11 minus 6. So 11 minus 6 is equal to 5. So whichever is least among these 3, that should be taken. The least is 4. Right? The least is 4. Where is the 4? 9 minus 5 is 4. So here I will take 4. Whichever is, because 3 arrows are busting from this event. One is going to 3, one is going to 4, one is going to 5. So we have calculated the minimum among these 3. How? 9 minus 5 is 4. 17 minus 9 is 8 and 11 minus 6 is 5. So 4 is minimum. Now, how many arrows are busting from the first event? 3 arrows are busting. Again, we take the minimum. Here, 9 minus 7 is 2. 4 minus 4 is 0. And 11 minus 8 is 3. Whichever is least. 0 is least. 4 minus 4 is 0. So here I will take 0. If you commit any mistake, you won't get 0 here. Right? When you get the LFT value 0, that means your calculations are right. So we got all EST LFT values. First time you may not be able to understand properly. So watch the video second, third time. The same steps you have to follow every time. Whenever we are going to calculate EST and LFT values. Now critical path. It is asking you to show the critical path. In theory video, I have already explained you. Critical path is the longest path from the first event to the last event, where EST, LFT values are same. The activities lying on the critical path are called critical activities, and there should not be any delay in the performance of those critical activities. Remember all these points. In theory also, it will be asked in examination. What is critical path? The longest path where EST, LFT values are same. See here EST, LFT values. There are different paths going from first event to the last event. The path 1 to 4, 4 to 6, 7, 5 is not critical because here 10, 11, both the values should be same. One path is going from 1 to 3, 3 to 5. 1, 0, 0, 9, 9, 17, 17. So all the EST, LFT values are same. But it is not critical because 8 plus 7 is 15. Is it 15 here? No, 17. So this is also not critical. Going directly from like this, 1 to 2, 2 to 5. These are also same, 0, 0, 4, 4, 17, 17. But again, this is not critical. Because if you add up 9 plus 4, 13. But here we got 17. So how to go? 1 to 2, then 2 to 3, 3 to 5. Like this we will go. 1 to 2, that means 0, 0, 4, 4. Both are same. So we have to draw double the line. This double line shows critical path. Here also 2 to 3, 3 to 5. So here the critical path goes from 1 to 2. The critical path 1 to 2. Then 2 to 3 and last one 3 to 5. That's it. Now duration, it is asking you to find the duration of the project. Duration of project is equal to, what is the duration for 1 to 2? 4 days. Plus what is the duration for 2 to 3? 5 days. Plus duration of 3 to 5 is 8 days. If you add up 4 plus 5 plus 8, 9 plus 8, 17. So here also you can say 17. 17 days is the duration of the project. That's it. This is the first problem where we have calculated EST, LFT values to find out the critical path and to find out the total duration of the project. That's it. Now, problem number 7. See carefully. A project schedule has the following characteristics. Activity 1 to 2, 1 to 3, 2 to 4, 3 to 4, 3 to 5, 4 to 9, like that. All the activities are given. Time estimates are given. This time should be written along with the activity. Construct a PERT network. Network we have to draw. Then compute TE and TL. TE is the earliest time and TL is the latest time. That means EST and LFT we have to calculate. Then find the critical path. Definitely for finding out the critical path we need EST LFT values. Without EST LFT values we cannot get the critical path. Total and free float for each activity. This is the new point. So up to critical path the same steps. Float we have to find out. I'll explain you how to find out the float. So first of all, we have to draw the diagram. See 7th problem, 1 to 2, 1 to 3. See carefully, I have already drawn the diagram here, 1 to 2 and 1 to 3. right? 1 to 2, 1 to 3. Then 2 to 4, 3 to 4. Here 2 to 4. And this is 3 to 4. Then 3 to 5, 3 to 4. 3 to 5. This is 3 to 5. Right? Then 4 to 9. This is 4 to 9. Next one is 5 to 6, 5 to 7. Two activities are busting from 5. 5 to 6 and 5 to 7. Then 6 to 8, 7 to 8. This is 8. 6 to 8, 7 to 8. Last one 8 to 10, 9 to 10. 8 to 10 and 9 to 10. That's it. So I have drawn the diagram with a larger circle because we need to calculate EST LFT values, right? Large circle consisting of three parts. The upper part is the even number. Even number I have given 1, 2, 3. No, it is given in the problem. 1 to 2. So 1 to 2, 1 to 3. Then 2 to 4. This is 2 to 4. This is 3 to 4. Then 4 to 9. Then 3 to 5, 5 to 6, 5 to 7, 6 to 8, 7 to 8, 8 to 10, 9 to 10. These are the activities. And durations are given 4, 1, 1. 1 to 2 activity, 4 is the duration. 1 to 3 activity, 1 is the duration. 2 to 4 activity, 1 is the duration. Then 3 to 4 activity, 1 is the duration. So whatever durations are given, write it on the arrow mark, right? Now we have to find out EST LFT values. See carefully. The first EST value will always be 0. We begin with 0. Now how many arrows are merging here? Only one arrow. So simply you add up. 0 plus 4 is 4. Here only one arrow is merging. So 0 plus 1 is 1. Right? Here two arrows are merging. So while moving forward, we have to take the maximum. For forward pass, maximum. For backward pass, minimum. So here forward pass, we are going from first to last. Maximum. Two arrows are merging. So 4 plus 1 is 5 or 1 plus 1 is 2. Whichever is higher. 5 is higher. 4 plus 1, 5. Right? How many arrows are merging here? Only one arrow is merging. 1 plus 6 is 7. Right? Here how many arrows are merging here? Only one. So 7 plus 4 is 11. Here how many arrows are merging? Only one. 7 plus 8 is 15. How many arrows are merging here? Two arrows are merging. So we need the maximum. Here 11 plus 1 is 12. Or 15 plus 2 is 17. Whichever is higher. 17 is higher. Only one arrow is merging. 5 plus 5, 10. Last event, 10th event, two arrows are merging. So we take the maximum. 10 plus 10, 17 or 17 plus 5, 22. So 17 or 22, whichever is higher. 22 is higher. So here I am taking 22. Over. EST values we have completed. Now LFT, backward pass. Coming from last event to the first event. Here we see the busting event. Wherever two or more busting event are there, we take the minimum. Right? Now last event LFT value will be same as EST value. EST and LFT values will be same for the first event and the last event. The first event will always be 0, 0. Finally will come to 0. Now 22. How many arrows are busting here? Only one arrow. So simply subtract. So 22 minus 5 is 17. Right? How many arrows are busting here? Only one. So subtract. 22 minus 7 is 15. That's it. Now how many arrows are busting here? Only one arrow is busting. So subtract 15 minus 5. You will get 10. How many arrows are busting here? Only one. So 17 minus 1, 16. Only one arrow is busting here. So 17 minus 2, 15. Now how many arrows are busting from here? Two arrows are busting. So we take the minimum. So 16 minus 4 is 12. 16 minus 4 is equal to 12. Or 15 minus 8. 15 minus 8 is 7. Whichever is lower, 7 is lower. So I am writing 7. Right? Now how many arrows are bursting from this third event? 2 arrows are bursting. Again we take the minimum. So 10 minus 1 is equal to 9. Right? Then here 7 minus 6 is 1. 7 minus 6 is 1. Whichever is lower, 1 is lower. So I have taken 1. Now how many arrows are bursting from here? Only 1 arrow. Only 1 arrow is bursting. So 10 minus 1, 9. Lastly, this event. So 9 minus 4 is 5, or 1 minus 1 is 0. Minimum is 0. So I am writing 0. That's it. We have completed all EST, LFT values. Now we need the critical path. Critical path is the longest path from the first event to the last event, where all EST, LFT values are same. There are different paths going from first event to last event. Different path. But some paths are there where EST, LFT values are same. And that path is called critical path. Now here 4, 9, it is different. So this is not a critical path. This is the critical path. 0, 0, 1, 1. This is a critical path. Now again we cannot go like this because 5, 10 different. So here 7, 7. This is the critical path. From 7, 7 again we cannot go 11, 16 because both are not same. Here 15, 15. So we come down. From this 15, 15 we'll go to 17, 17. Last one will go to 20, 20. This is the critical path. The critical path will be expressed by double lines. Double lines we will draw. So this is the double line showing critical path. This is the critical path. This one, and this one. So here I have written critical path. The critical path is 1 to 3. First event to third event. Right? Then third event to fifth event. Then fifth event to seventh event. Then seventh event to eighth event. Last one, eighth event to 10th event. That's all. This is the critical path. And duration of the project. Add up all the duration of the critical path. The critical path, the duration is 1 plus 6 plus 8 plus 2 plus 5. You will get 22 days. That's all. So we have drawn the network diagram. We have calculated all EST and LFT values. We have found out the critical path and the duration of the project. Lastly, it is asking you to calculate the total float and free float. For finding out total float, free float, this table is required. 2 tables are required. Now I'll explain what you have to do in these 2 tables. Total and free float for each activity. Activity 1 to 2, 1 to 3, 2 to 4, 3 to 4. Whatever is given in the problem, same activities I have copied down. Now duration. The same duration, whatever is given in the problem, I have taken. It is denoted by Tij. Tij. This is the symbol we give for duration. Right? Now 2 broad columns we will make. One earliest column, second latest column. Broad column. In this earliest column, 2 subcolumns. Latest column, 2 subcolumns. The subcolumns are start, finish. Start, finish. Start is ESIJ. E stands for earliest. S stands for start. Earliest start IJ. IJ means ith event to jth event. Every activity will have a beginning event and an ending event. I is the beginning event, J is the ending event. So every activity ESIJ. Then F stands for finish. EFIJ, earliest, finish IJ. Latest start LSIJ. Latest finish LFIJ. Right? These are the columns you have to make. First 2 columns we have copied from the problem. Now ESIJ. Now you have to remember what is the meaning of this ESIJ. ESIJ is equal to EST of the beginning event. EST of the beginning. Every event we are having first value EST and second value LFT. This first value is EST and second value is LFT. Remember this. So ESIJ stands for EST value of the beginning event. So here this is the beginning. First event is the beginning and second event is the ending event. Right? So what is the EST of 0? EST of first activity? 0. So first activity EST is 0. Here also first activity EST is 0. Second event. The second event EST is 4. So I have taken 4. Third event EST value is 1. Here I have taken 1. Third event, the EST value is 1. Fourth event, the EST value is 5. Fourth event, the EST value is 5. Then fifth event, EST value is 7. Here you can see 7. Fifth event, 7. Then here sixth event. The sixth event EST value is 11. Then sixth event EST value is 11. I have taken. Then seventh event EST value is 15. Eighth event EST value is 17. Then ninth event EST value is 10. That's all. So all these are the EST of the beginning event. ESIJ is equal to EST of the beginning event. Now EFIJ. Now remember, see here. EFIJ is equal to ESIJ plus TIJ. Remember this. Whatever ESIJ we got, to this we add TIJ. So 0 plus 4, 4. 0 plus 1, 1. 4 plus 1, 5. 1 plus 1, 2. 1 plus 6, 7. Like this we have calculated EFIJ. So we got two columns, ESIJ and EFIJ. Now LSIJ, LFIJ. So first of all, LFIJ is equal to LFT of the ending event. LFT of the ending event. Now here these are the ending events. Second number is the ending event. So what is the LFT of second? See here. LFT of second event is 9. So I have taken here 9. LFIJ. Now third event. What is the LFT of third event? 1. I have taken 1. Fourth event. LFT of fourth event is 10. Here also fourth event LFT is 10. Fifth event LFT is 7. Then ninth event LFT is 15. So here I have taken 15. Then sixth event LFT is 16. Then seventh event LFT is 15. Then eighth event LFT is 17. Again eighth event 17. 10th event LFT is 22. That's all. So LFIJ is LFT of the ending event. Right? Now LSIJ. Finally we need LSIJ is equal to LFIJ minus TIJ. Now subtract the duration. So 9 minus 4 is 5. 1 minus 1 is 0. 10 minus 1 is 9. Here also 10 minus 1 is 9. 7 minus 6, 1. 15 minus 5, 10. 16 minus 4, 12. 15 minus 8, 7. 17 minus 1, 16. 17 minus 2, 15. 22 minus 5, 17. 22 minus 7 is 15. That's all. So finally we have completed the first table. Again I repeat, in this first two columns I have copied from the problem. Two broad columns, earliest, latest. Two sub columns, start, finish, start, finish. ESIJ, EFIJ, LSIJ, LFIJ. Right. Now finally we have to find out the floats. First two column, as usual, activity column, duration. Same activity duration, same two columns. Now total float. The formula for total float is LSIJ minus ESIJ. So here already we have LSIJ. This is the LSIJ. Minus ESIJ. This is the ESIJ. LSIJ minus ESIJ. So first you copy down all LSIJ values. This 509, 509, 9110, 9110. All the LSIJ values minus ESIJ value 0041. So 0041. Subtract 5 minus 0, 5. 0 minus 0. 9 minus 4, 5. 9 minus 1, 8. 1 minus 1, 0. 10 minus 5, 5. This is the total float. Remember the formula for total float? LSIJ minus ESIJ. Now lastly, free float. The formula for free float is total float minus head slack. Total float already you have calculated here 5058. 5058 minus. So from total float you have to subtract the head slack. Head means second event. First number is the tail event. Second number is the head event. The first activity head event is 2. Slack. Slack is the difference between LFT and EST. LFT minus EST is called slack. Write it down immediately. Right? So head slack. Second event, what is the slack? This is the second event. What is the difference? 9 minus 4 is 5. I have taken 5. Now third event slack. For third event 1 minus 1, 0. So I have taken 0. Fourth event slack. This is the fourth event. 10 minus 5. I have taken 5. Then again fourth event 5. Fifth event slack. This is the fifth event. Slack is 7 minus 7, 0. So here I have taken 0. Right? Then ninth slack. Ninth slack is 15 minus 10. 5. Here I have taken 5. Sixth event slack. 16 minus 11 is 5. Here I have taken 5. Then seventh event slack 0. Seventh event slack 0. Eighth event slack 17 minus 17 0. Eighth event slack 0. 10th event slack 0. And 10th event slack 0. Now simply subtract 5 minus 5 0. 0 minus 0 0. 5 minus 5 0. 8 minus 5 is 3. Like that you calculate the free float. So in this problem, a major part, a new concept we have understood. First, you must know how to draw the diagram. If you are unable to draw the diagram, remaining all will become 0. You cannot be able to calculate anything. First step, correctly you must draw the diagram. It needs practice. 2-3 times. You have to repeat it. So after drawing, find out the estimates. EST, LFT values you have to find out. The critical path is the longest path from the first event to the last event where EST, LFT values are same. Find out which is the critical path. What is the duration of the project? Then you have to find out float. For float, this EST, earliest, latest, earliest start, earliest finish, latest start, latest finish. That formula. That's it. So in this first video, I have explained you 7 problems. It's a lengthy video, but it's very important. If you have watched this video 2-3 times, then definitely you can enjoy learning how to solve the problem on network in the coming videos. So if you are satisfied with my lecture, give a like to the video. Share my channel among your friends, among your groups, so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe my channel if you have not yet subscribed. And by the super thanks which is given below my video, inshallah we will continue the next problem in the next video.